students, these days we all know that we are having sun in the center part and all the planets are revolving around it due to the gravity. Okay, that is true. Because of the technology and high advancement, we know that how things work in the solar system and how every planet, every other celestial objects is working in this space. Okay, but earlier scientists considered that the sun is not a center of the part. Okay, so earlier the scientists considered that the earth is at the center of the solar system and other planets and including the sun is also revolving around it. Okay, that is the earlier part. But later on, some scientists like Copernicus has come and they have suggested their own theories that only and only sun is in the center part of the solar system and other planets are revolving around it. But still, there was one contradictory part, that then how some planets appear at the part of the summer days and some winter days. So that all things, including the other postulates of other scientists taken by the Kepler, and Kepler suggested some laws of planetary motions. And here we are going to study how Kepler's given his theory that how does the planets are revolving around it and where does the sun is actually situated. Okay, so here is the first postulate that has been given by the Kepler is that the planets move in elliptical orbit with the sun as a focus. Okay, so the earlier scientist suggested that the sun is the center part of this orbit and the planets are revolving around it. But Kepler told us that it is not a circular path, it is a elliptical path. And now what is elliptical? Student, this is a path elliptical which has a shape of like egg shape. Like egg is a oval shape. So in the same manner, we are having this circular shape, but somehow it is elongated with having two focus. Like in the case of circle, we are only having one center point. But in case of ellipse, okay, it is having two center points, that is the focus 1 and focus 2. So he suggested that the shape of the orbit that the planets are moving is not a circular, it is elliptical path, and out of these two focus, on the one focus we are having our sun. Let's suppose we are having our sun on this point and the planet Earth is revolving around it in this manner. Here is nothing, okay? This focus point I have just said that the F2 is here, just the point that the ellipse has having two focus point. But here we are not having anything, only on the first focus we are having the sun and Earth is revolving around the sun like this in this manner. So the first thing he suggested is the path we are taking is wrong. The path the planets are revolving around it is in this manner, especially for the case of our own planet, that is the Earth. Now, the second postulate that has been given by the Kepler was a planet covers the same area of space in the same amount of time. Now students, this is a very deep connection and you got to know now how does the speed of the earth changes according to the distance from the sun. You know that we are having an elliptical path of the earth. It is not a circular according to the first part we have seen, and here we are having our sun, and let's suppose this earth is rotating and revoluting around the sun in this path. Okay, now the second postulate suggests that when the earth is here, let's suppose the earth is here and it is connecting this point to this point. Okay, it has been shifted from here to here, so it has taken some time to move from here to here, and when we connect, like a line is there and a line is here, and when we connect the line, so we are having certain area here. So the area that has been swept, like if we have connected, let's suppose this earth and the sun is connected with a string. Okay, so when the earth is moving towards here from this point to this point. Now this string will have moved from here to here. It has been shifted also, and the area swept by this string will be this part. Okay, now the earth, let's suppose, is here and here. Okay, now again the string part is connected. The string part is connected. Now the area swept will be this part. So now student, what does it suggested? It suggested that the area in this case and in this case is same, because we need to keep the time same. You know that the time that has been covered by the earth to revolute, to take a one round around the sun, is 365 1/4 days. Okay, and we evenly divided all the days to the months, right? We are having 31 days and 30 days. Almost we are having the same amount of numbers. Fine. So the time that has been consisted taken by the earth planet is the same to cover the path. Okay, and again it also suggested that the earth here is far from the sun, and in this case the earth is very, very close to the sun, because it is an elliptical path. So one at a time, the earth has to be far and the earth has to be close. Okay, that is also true. Now students, as you can see that in this case, so when the Kepler calculated that the area here, when we have taken the equal amount of time, that the time here and the time in this case is equal. So what is changing? Because time is same and the area swept by the two conditions is also equal. Then what is changing? So here student, the speed of the revolution of the earth, like shifting from here to here, is changing, and the shifting from here to here is changing. Speed of the earth is changing. ये इस तरीके से जाता है, like when it is far from the sun, then it is moving slowly, and when it is coming to close, like अब पास आने वाला है तो ये बहुत fast लिया जाएगा. Then again slow, and then again fast, then again slow, then again fast. Okay, so the part of the earth which when it is nearby to the sun, it moves very quickly because it has to cover that distance in equal amount of time. Because the area swept, according to the second postulate, the area swept by the planet, when we connect this thing, it is equal. So for that, the speed has to be changed. Okay, so this is the second postulate of the Kepler's law of planetary motion. Now students, the third postulate that has been given by the Kepler's law is the planet's orbital period is proportional to the size of its orbit. Yes, so size of the orbit, right? Okay, we are having an elliptical path. So considering that the distance of the earth and the sun, we need to take it like here in this case we are having the more distance, and in this case we are having very less distance. So can we take the average part of the distance? Okay, so let's suppose we have taken the average of these two and we are having supposingly the certain distance, and we are considering it as the r part. Okay, so r is the average distance between the earth and the sun. Now the time to complete the revolution of the earth planet from one point and come to this point again. So the time taken here will be capital T. So according to this, he suggested that this time period is depending upon the distance. Okay, if the planet is very, very far from the sun or any big mass, then it will take more time to complete one revolution. And if it is very close to the sun, then it will complete one revolution very quickly. Okay, and that gives the postulate that we are having T square is directly proportional to the R cube. That the distance of the planet to the sun is, when we take the cube part of it, so it is directly proportional to the time square. The time, whatever we need the time, is the square part, and it is directly proportional to the R cube. So this is the third postulate that has been given by the Kepler's planetary motion.